Okay, hello all. Welcome to another video of data science with Julia. In this video, till last video we saw about this Titanic data set and all those stuff. But in this video, we'll try to look into a thing called entropy. Okay, like I'll tell you what entropy is yeah, like you will face a lot of questions like what is this name and all those stuff. Okay, I also heard that this name was given in computer science and a field called information theory and all those things just to confuse people. Computer science people during the past like to confuse others. They've come up with different names like entropy, and there is another name called GNU. Okay, but you need to know like what GNU is, because without that, all these things cannot be possible. So just go and visit gnu.org. It's actually GNU. Like if you're looking in India, it'll be GNU, and you'll be wondering why it's called GNU and all those stuff. I'm not going to tell those stuff in this video. It's for you to discover. If you like computers, and if you want a career in computers, and if you like computers, you need to find these things out, of course. But this is slightly away from data science topic, so I just don't want to tell why they name like that and all those stuff. But entropy is a very integral part of data science. I don't know how they derived this formula and all. Let's say okay, let me just okay, this is the Wikipedia page about entropy, that is in information theory, how we are using it and all those stuff. But okay, so let me just jump into it. So I'm just importing a thing called mllib.js. So don't worry about it, what it is and all those stuff. This is like I'm just writing my own machine learning library. Okay, why not? This entire video series and my blog Data Science with Julia, that's so here. Now it's lagging behind these videos because videos are far easier to make than to blog. Okay, so but yeah, anyway, I'll be converting this video to blog and putting it over here. So it is all about like, okay, look, I can do almost any data science projects or machine learning projects. That's one thing, but I need to understand what goes behind the hood, right? That's why I just took this journey, right? So that's the thing, and I'm just writing my own machine learning library. Not big, very small library right now, but yeah, it might go big, and we need to manage and all those stuff. So that's the thing, like very small library, just 60 lines of code. With this, I can do some machine learning tasks. So if you think machine learning and data science is complex, please think again, right? So that's the thing. And yeah, if you want to learn about it, follow these video series, follow my blog and all those stuff, so that like you can learn with ease. Like you will be confident, like, okay, look, you can do it and all those stuff. Anyway, let me just restart the kernel and run all steps. Okay, so this is there. Like, okay, if at all you're having some big error in Jupyter notebooks, you have just messed it up something, just do this, kernel, restart kernel and run all sets. Yeah. So that's it. Okay. So look, I've just included this. This is how you include other programs in Julia. So there is this mllib. It's in the same folder, right? So over here, I'm just including it over here. And this is a formula of entropy. Okay, and look, this cell is of type Markdown. Okay, and here I've used a language called latex. Okay, so latex math. I think I'm using latex math. Yeah. So right, yeah, I think I'm using a thing called latex math, and okay, latex math in Jupyter Lab. Okay, so there are some things like where you can just go and find it out how to use this latex in Jupyter Lab, not this one. Math equations. Okay. In Jupyter Notebook, actually. Look, I just want to say one thing. This entire thing is called Jupyter Lab, like with this all this menus and all that stuff. Each and everything you're seeing, right? This files.ipynb, that's called as a notebook. This is a normal text. .txt is a normal text. Okay, so don't confuse with that. Functions.ipynb, that's called as a notebook. Okay, and the collection of notebooks is at the left. Okay, so and this entire environment is called Jupyter Lab, and I think I'm using a thing called latex math over here. So like many times I used to do. Okay, so what to say, like stuff without even knowing what it is, and I just found out like, okay, now also I'm just doing it. So I'm not 100% sure, but yeah, I am very sure that this is latex mat that we are using in Jupyter Lab, right? So don't ask me how I found out and all those stuff. I just do stuff. Okay, so that's the thing, right? Sometimes without even thinking, right? So like possibly because of experience, right? So maybe. Okay, so this is the formula for entropy. Okay, so it is. Okay, let's say like you have. Okay, let me just introduce the formula and then tell you. You have like some elements. Okay, like you just have okay, like 10 fruits in a basket. Okay, maybe two are apple, two are orange, and then eight are sapota. I don't know how many people know about sapota fruit, but it's one of my favorite. Okay. Okay, so you calculate the probability of orange and log that probability. Okay, that is using the log function. Multiply it. Okay, and yeah, and of course you need to minus it. So like if it says, let's say if it's 0.2 or if it gives some value. Okay, so just minus it. Okay, and keep on doing it for apples and then for sapota and all those stuff. That will give you the value of entropy. So now what is this entropy? I'm just telling you entropy, it's an information theory. It tells about the impurity. Okay, so if the bag just okay, if the basket just contains only apples, the entropy will be zero. If it contains apples, oranges, sapota, mango, bananas, and all those stuff, entropy will be high. If it only contains sapota and mango, the entropy will be lower than having like five or six fruits or something like that. So it's kind of measure of impurity. Okay, and so that is entropy. So this thing we'll be using in explore. We'll be using it while we explore decision trees. Okay, so that's how it is. And another thing, what I just found out is, yeah, I found out you can enter math like this in Jupyter Lab. And okay, so another thing, what we'll be doing is like, okay, in Julia, you know, this question mark is used to ask help. Okay, so Julia is there, and okay, like Julia, and this question mark you can ask help, and you can put log and all this stuff. So yeah, you're just getting this documentation. You can do the same stuff in Jupyter Lab too. But yeah, I've colorized over here. You go and read my blogs or look into this playlist uh, before you will know how it was colorized and all those stuff. I used some package to colorize it. So I just forgot it, right? So that's the thing. And if you look over here in entropy, I'm using log2. It's not necessary to use only log2. You can use whatever natural logarithm and all those things. Okay. So if you want like learn about logarithm, so logarithm tutorial, I think it will tutorial. It will land in Khan Academy, I think. Okay, so okay, logarithms. Okay, there is some tutorial. Okay, but I just like this Khan Academy because you can track your progress. But one problem I find with Khan Academy is like my native language is Tamil. Okay, so Khan Academy is totally English, right? So some questions they ask I don't understand, and image. Yeah. So you just go to introduction to logarithms. That's the thing, and try to learn it, or try to learn it from Wikipedia and all those stuff, right? So. Mm, Logarithm, right? If you don't know, but I don't want to go deep into logarithm because this, okay, yeah, you should learn what to say from scratch and all those stuff. But yeah, I don't want to be. This has this thing as a very pure mathematical class. Let's say like log 2 of 64, what it is. Okay, so we know that, okay, 2 power something should be 64, right? So 2 power 6 is 64. So log 2 of 64 is 6. So that's how logarithms work. Okay, so I just want to be brief. So yeah, excuse me if you don't understand, but this is much more about data science. Okay. But of course, yeah, it also need to include math. But yeah, if you are not very sure, yeah, please go and find it out yourself. Otherwise, tell me to do something like another series like mathematics for data science. I'll be happy to do it. Okay. So 2 power 3 is 8. So if you put log 2 of 8, it should be 3. Okay, so that's how it is, right? And now we'll find out something about entropy. So you just have fruits. Everything is apple over here, right? And yeah, okay. Now we have in MLlib, I have a function called counter. So if you pass an array, it will just give like, okay, like what is the count of this thing? Apples. Okay, so it will give 4. Okay. If there is orange, 2 orange, it will give apple 4, orange 2. Okay, so that's how it is. I'm just testing that function. I don't know why I test it, but yeah, it might be used in the future. Okay, so now we'll see the probability of apple. So it is 4 by 4, 1. Okay, so and what is entropy? Okay, so it is minus. So we'll just obey this formula, right? And probability of apple. So I'm just putting 1 over here. Explicitly, I'm putting 1 over here. I could have put p apple, but just to make sure like things okay, like I don't know, like I could have just put like p apple out here and log 2 of 1. So that is once again like this probability of apple, right? I'm just taking the entropy 0. So there is no impurity. So entropy is totally 0. There is no impurity over here. Entropy is totally 0. Okay, so that's how it is. And now we'll mix one orange with this apple. So we are just mixing one orange with apple. Probability of apple now becomes 4 by 5 and probability of orange becomes 1 by 5 because there are 5 elements, 4 are apple and 1 is orange. So this probability of apple is 0.8 and probability of orange is 0.2. Okay, now this entropy becomes like, okay, so this formula, right, minus probability of log of probability. Okay, so that's how it is. So minus probability of apple, that is 0.8, into log of probability of apple, that is once again 0.8. Okay, and then minus okay, probability of orange 0.2, log of probability of orange 0.2. So what it is, 0.72. So just imagine, just by including one orange in this apple, sorry, in this fruits, you're just adding impurity and entropy just rises. So that's how it is. Now let's imagine like there are equal number of apples and orange, like 1, 2, 3, 4, 4 apples and 4 orange. So the apple probability should also be 0.5, and this is, we're just calculating this individual entropy. And similarly for what to say orange also we are just calculating, assuming like there are 4 apples and 4 orange. Okay, and now the entropy is 1, so it's far higher than this one. So if you have 4 apples and 4 orange, then the fruit basket is more impure, right? So entropy, you can imagine like it's a measure of purity. Okay, so that's how it is, right? And okay, so that's how it is. And another thing is like, yeah, we have, okay, let's say we have another fruit like I don't know, like sapota. I don't know what sapota has been called. It's been called something like, I'm not sure what it's been called in English or something, right? Or it is an English word I'm using. I'm not sure. So okay. So like, okay. So let's say like we have another 3 fruits in the basket. One is having probability of 0.3, right? Another is having probability of 0.3. Another is having a probability of 0.4. So we have 10 fruits. Okay. Possibly 3 are apple, 3 are orange, 4 are sapota, right? So that's how it is. Now we are just plugging into this entropy. So entropy of apple, orange, sapotas, and look, now this is more impure, right? Like there are three fruits. Okay, so this is more impure, and so the entropy is 1.57, right? So that's how it is. And okay, and I've written a function called element probabilities. Okay, so here. So what I'm just doing is, like, if you have followed this thing, I would have written a function called counter. So like, and similarly, I've written a function called element probabilities. So that's how it is. And so in this over here, I'm just using this thing called counter. Okay, so over here I'm just using this function called counter. So this counter will fetch count of elements. Okay, the key will go to key and value will go to value, and I'm just calculating the probabilities of this. Probability is nothing but the number of apples in a basket to total number of fruits, that is number of elements. Number of elements is nothing but length of array. So you just give like apple, orange, sapota, banana, jackfruit, and all those stuff. So that's how it is. So, and it'll just return the probabilities. Okay, and entropies, this function is being used in this entropy. Okay, so I'm just getting the probabilities over here, and I'm just doing this like output is nothing but your minus, that is like the summation of what to say, the value, that is the probability value, and the log of the value. So that's how I'm just doing. So this equation, you can see it over here. So look, this counter and all, it was, we did it for k nearest neighbor and all those stuff, and we are just using it over here. So if you see, like, there are very, very basic stuff, okay, like in machine learning, like when that once when developed can be used in many, many places. So that's how it is. That's what, yeah, I'm just discovering. Like I won't say like I know and all those stuff, and that's how it is. So now this fruit has like apple, orange, and we just found out with our own hand like it is 0.721. So let me look at entropy of fruits now. Okay, so and it is giving 0.721 or 0.722. Okay, so it is giving the same value like here. So our entropy formula is our function is right. So now we have entropy, which we can in the future use it. Okay. So like in the video previous, you would have seen about like the Titanic analysis and all those stuff. Now we will see whether, okay, like, look, this is actually applying entropy on Titanic. Like, not now. In the next video, we'll apply entropy on Titanic and see how it goes. And that will form our basis for decision tree. But before that, I would like to present you another blog. Like, okay, like it is my blog only. Like, I'm, I have analyzed this iris data set. So, like, I don't know where I put it. Okay, IRIS, not here, not here. Okay, I've analyzed iris data sets using data frames and all those stuff. So I just want to say, okay, I can query it over here. Iris. Is there iris? No. Very nice. I don't know where I put it. Okay, but I have done a thing where we are trying to predict this iris data set, and I am not sure where I put it. Okay, so that will also be another video. Okay, so like, because in that I would have used data frames a bit differently, I think. Okay, so okay, yeah, I am not able to find it. Oh, okay, yeah, it's over here. It's almost page 2 of 6. Okay, iris data analysis. Okay, so we'll be analyzing this data set, And so yeah, and then we'll just move on to this one, like this decision trees and all those stuff, right? So that's how it is, right? So anyway, thanks for watching. I hope you like and subscribe to this channel and all those stuff. So anyway, even if you don't, yeah, it doesn't matter. So like, um, anyway, like enjoy learning data science and know that it's not so complex and all those things. So yeah, bye.